So just now we have had a look at at polar bond. So now we're going to look at non-polar bond. So tadi kita tengok polar bond, so now it is non-polar bond punya term pula. Okay, so kalau kita tengok polar bond tadi, we have looked at the differences between electronegativity in a bond. So sebab kita tahu satu bond akan ada dua atom. Okay, so akan ada dua atom. Dan kalau electronegativity dia berbeza, or there is a big difference between the electronegativity, then you will have an asymmetrical distribution of electrons. Maksudnya, kalau dua atom yang buat bond tu, electronegativity dia berbeza secara ketara lah, beza besar. Okay, so apa yang akan berlaku adalah bond tu, dia punya elektron dia akan ditarik ke arah atom yang electronegativity dia lebih tinggi. Okay, and because of that we will create a partial negative and partial positive. This is what we looked at earlier. But now we look at the situation where we have two atoms, usually the same atoms. Okay, sebab kalau atom dia atom jenis yang sama, contohnya chlorine dengan chlorine, here we have chlorine and chlorine and hydrogen and hydrogen. Okay, so what happened in this situation would be like this. Okay, so kalau kita ambil hydrogen for example, electronegativity between this hydrogen and this hydrogen is the same, and because of that electron dia akan spend masa dekat tengah. Okay, 50% spend masa dekat hydrogen here, 50% dekat here. So on average it will be exactly in the middle, and because of that there is no asymmetrical distribution of electron. Maksudnya elektron dia sama rata, dan disebabkan oleh itu dia tiada kutub. Okay, and this is the concept of polarity, and the concept of polarity is explained through this here. Okay, so let's have a look at that. So in conclusion, before we proceed to what this symbol is, okay, we look at polar bond and non-polar bond. So polar bond kita ada kalau dua atom tu berbeza, hydrogen dengan fluorine, hydrogen dengan chlorine, aluminium dengan chlorine, for example in AlCl3, xenon dengan fluorine, all that, they are difference in electronegativity, and because of that the electron will spend time asymmetrically between the two atoms. Maksudnya sometimes, most of the time dia akan ada dekat atom yang electronegative, sometimes dia akan ada dekat atom yang tidak electronegative itu. Okay, and this creates the polarity that we have discussed earlier. So now let's have a look at the next page, on page 38. So kalau kita tengok dekat sini, this is a water molecule. So kalau kita guna Vesper theory, this one would be, dia ada dua lone pair dekat situ. So it is A, B, 2, E, 2. So electron pair geometry dia would be tetrahedral, and molecular geometry would be V shape. Okay, so it is V shape. Okay, and this molecule right here, kalau kita tengok, kita ada hydrogen dan juga oxygen. So we have these two differences. Okay, hydrogen is less electronegative berbanding oxygen. Okay, and because of that there is a difference in electronegativity, thereby the electrons are being drawn towards the oxygen, like that. Kita akan selalu rujuk guna arrow ni, this polarity arrow. Okay, yang ada positif ni dekat electropositive atom tu lah. Okay, so if we look here, the electron moves or spend time mostly on the oxygen atom, and this is how the molecule looks like, and the representation of the orbitals, molecular orbitals dia, dan ditunjuk dekat mana elektron tu fokus. So warna merah, lagi merah maksudnya lagi negatif. So kalau kita tengok in this structure right here, the blue means positive lah. Blue is positive, red is negative. So kalau kita tengok dekat hujung oksigen ni, it is very red. That means the electrons is focusing over there, and this molecule has it has a partial negative charge here and partial positive at the bottom right there. And because of that, this whole molecule will have a total resultant dipole like that. Okay, so we call it resultant dipole. Okay, resultant dipole. Okay, right, so dia ada satu arah like that. That's the resultant dipole. Now let's have a look at the concept of this one here, dipole moment. So dipole moment, okay, dipole moment is it is symbolized using the symbol mu, small Greek letter mu. Okay, and this is a measure of molecular polarity. So dia punya magnitude, magnitude how polar it is, kita ukur guna mu. Okay, and the unit is debye. Okay, debye d. So how do we calculate this? The mu is equals to q multiplied by r, where q is the charge difference ataupun charge, okay, and r is the distance between two charges. So kalau lagi jauh charge tu, okay, lagi jauh dia punya charge separation tu, ataupun lagi panjang pun, that means that dia punya, what do you call it, the dipole moment would be larger. But we don't have, at your level, we don't have to worry about the calculation using this. It is not important. You just need to know the formula only. So that is important. So that means that kalau kita tengok dekat sini, kita ada difference between two atoms. Okay, there are two different electronegativity here. Okay, different electronegativity here, positive and negative. And because of that, kita ada mu dekat sini, and the mu is not zero. Okay, and because we are not calculating, kita tahu yang mu dia bukan zero. And this one also mu is not zero juga. And it is moving towards the same direction. So kalau kita tengok, we have like this, we have like that. And the reason why kita guna perkataan resultant ni, as you are familiar in physics, resultant ni selalunya pakai vector, something that requires vector, because dipole moment is a vector measurement. Okay, so it's a vector measurement, and because of that, the direction or the shape of the molecule is very important. Okay, so kalau kita tengok contoh, another contoh di mana kita ada resultant dipole dia berbeza. Kalau kita tengok dekat sini, if we draw in a vector diagram, kita ada arrow macam tu, like that, and this one kita ada arrow like that. So the punya resultant like that. This is the resultant. Mu is equals to 0. So mu resultant is not equals to 0 sebab dia ada direction like that. Okay, but then there is situation whereby the bond is polar but the molecule is not polar. Okay, and before we jump into that, we look at this. Sebab kita tengok molecule ni ada negative positive charge and resultant dipole is not equals to 0. That means that this molecule is polar. So this is a polar molecule. So let's have a look at another example here. Kita ada CO2. So if we look at this CO2, this is AB2. Okay, this would be the molecular shape dia. Dia punya class is AB2. That means that the shape is linear. Okay, it means that the angle here is 180 degrees. And we look here, carbon to oxygen. Oxygen is more electronegative, and because of that we have like that. But if we look at the arrow, it is moving exactly opposite direction at 180 degrees. That means that the resultant dipole, mu resultant, okay, is equals to 0, walaupun dia punya bond adalah polar bond. So molecule ni, because dia tarik sama rata sebelah kiri dan sebelah kanan, because of that, this molecule would be non-polar. Okay, so it's different than H2O. H2O is polar and CO2 is not polar. Okay, so the rest of these are basically what I have explained just now. A molecule is polar. So to summarize this, a molecule is polar if the net dipole moment, ataupun kita panggil sebagai resultant dipole is not equals to 0. Atoms arrange asymmetrically usually, ataupun bond dipoles do not cancel. What it means by cancel, bila kita kira vector dia, okay, kita tak payah nak kira guna value pun, kita boleh agak just by looking at the shape itself. Okay, this is why the concept of VSEPR is very important for you to imagine in 3D space instead of 2D structures. Sebab bila kita nak tengok molecule yang tetrahedral or molecule trigonal bipyramidal, for example, it can be quite an interesting situation. Okay, a molecule is non-polar Okay, so kalau polar, dia punya resultant dipole is equals to 0. But if it is a non-polar molecule, it is equals to 0, like this one. So CO2 is non-polar, H2O is a polar. Okay, so